All right, so today we're going to review section 1.6, which is other types of equations. And these are the notes. We're going to take these in class, but this is a backup for you to have. And I'm going to start with going over each example. Obviously in class we'll have much more discussion. So here's example 1 of section 1.6. And again, we're looking at other types of equations. And one thing that I will mention, and if I don't mention it in class, you're going to hear me mention it here. There are 12 parent graphs that I want you to download the page that basically summarizes them. The 12 parent graphs, and learn them. Learn their equations, learn their patterns. Because if you learn that particular sheet of information or set of notes on those 12 parent graphs, you're going to feel very good about the rest of the chapter. This is basically the summary of the class. So in example 1, we are solving a polynomial equation by factoring. And so they're giving you, in this case, it looks like they're giving you 3x to the fourth is equal to 27x to the second power. And so step 1 is always going to be to subtract the 27x squared. Put everything, basically, move everything to one side of the equation. So if you choose the left, go ahead and subtract the 27x squared to both sides. Now once you do that, you're left with 3x to the fourth minus 27x squared equal to 0. And now we can factor. Notice this cancels. The reason what you want to do next here would be basically to take out what's common to both. So 3 goes into 3 and 3 goes into negative 27. So we know we could take out the 3 for sure. And of the two polynomial values, the two variables, the x to the fourth and x to the second, I'm going to take out x to the second. Now remember, 3x squared times x squared will give you 3x to the fourth. We want to complete that. Minus, obviously, 9, because 3 times 9 is 27. And obviously, we don't need anything else after that, because the x squared is already there. The idea is that when you distribute this again, that you can actually go all the way back to the original. That's how you know you're doing this correctly. Now at this point, if you notice, you're left with the x squared minus 9, and that could still be factored further. So we are going to go ahead and look at that. This is what we call a repeating zero. So basically in this case, we would say 3x squared is equal to 0. Obviously divide by 3. You end up with x is equal to basically plus or minus the square root of 0, which is 0, right? On this side, we have an a squared minus b squared special product. So we know that we need to factor this down so that we have x plus 3 times x minus 3. And if I solve for x in this case, x is equal to plus or minus 3. Granted, this is a set of solutions for this equation, but if this were an application, remember the distance is always positive. There's no such thing as negative distance. And so, yes, and I mean, in this case, they're not asking an application question, they're just asking a basic question, so we're answering. That is your solution set. All right, if you feel that you mastered this, let's try one in the classroom. This is your try. You can pause the video if you're doing this at home. And go ahead and try and solve for this. So we have 4x to the fourth minus 12x to the second. And so we're going to solve for this equation. Go ahead and pause the video now. And I'll go ahead and give you the solution back down here. So once you start the video again, you'll have the solution. This solution ends up being negative square root of 3, 0, positive square root of 3. And that's your solution for that equation. All right, I'm going to continue on to example 2. In example 2, we're still solving a polynomial equation by factoring. This time they give us x cubed plus x squared, and that is equal to 4x plus 4. Once again, step 1 in this case would be to subtract the 4x and the 4 and bring it to the left side. The reason I'm subtracting them, in this case, they're both positive 4x and positive 4. You always do the opposite. So if I bring negative 4x minus 4 on this side, what's going to happen is basically this is going to cancel on the right hand side. These will cancel, leaving you 0. And this is expanded to x cubed plus x squared minus 4x minus 4. Remember, they're not like terms, so you can't combine them. Now, once you do this, you can actually use factor by grouping again. So what we do in factor by grouping is we split the equation just before the next operation. And we're going to take out what is common in these first two terms, so which obviously this is x squared. This leaves me x plus 1 as a factor. Over here on this side, I'm going to take out the negative 4. And this is x plus 1. Now keep in mind that both of these have to be identical for you to use factor by grouping. And if they're not identical, we cannot use them. It's not factor by grouping at that point. We have to use some other method. The reason why we want that to be the same is because basically we're going to combine these two. That gives us x squared minus 4 times x plus 1. And again, is obviously is equal to 0. So as you can see, we have another binomial where we have a minus b times a plus b. It's a special product. It's the a squared minus b squared as special product. So we factor this down. So this is x minus 2 times x plus 2, and I can't factor the x plus 1, so I'll just bring x plus 1 down, and all of that's equal to 0. So my solution for this equation, negative 2, positive, or negative 1, positive 2. And that's my solution for this equation. Again, if you're doing this at home, I would like for you to pause this video and try this equation. So we're going to solve by factoring. And we have 2x cubed plus 3x squared. This is equal to 8x plus 12. So pause the video, and I'm going to go ahead and give you the solution in a few minutes. The solution for this one should end up being negative 2, negative 3 over 2, and 2. Now I am going to take a moment to use this example as how we can actually reverse these answers to be our actual factors. So you see how this is x minus 2? I know that this factor is actually x plus 2. You see how that factor is negative 3 over 2? Oh, actually, let me do this one real quick. This one is actually x minus 2. Okay, let's go back to this one. That means that I have a 3x and a plus 2 here. The reason I know that is because if I take 3x plus 2 and I set it to 0, the first thing I'm going to do, Actually, no, my apologies. This is actually not 3x plus 2. This is 2x plus 3. This is 2x plus 3. Because the first thing I'm going to do is I'm going to subtract that 3 on both sides. And to solve for x in this case, so I'm left with 2x equals negative 3. And then I'm dividing by 2. So x is equal to negative 3 over 2. That's important to know. There's a reason for that. And because you noticed on the tests, the sample PSAT, and on the SAT as well, they'll give you factors and they'll ask you to solve for the equation. We are eventually going to get to the point where you're going to learn how to do the function where they give you f of x is equal to a formula, and they're going to give you a of x, and this becomes x minus c1, x minus c2, and x minus c3. And eventually, when we get to the higher level questions, I'm going to show you how we know, for example, if it's a cubic function, we have to have at least 3 of these values, 3 of these binomials. As far as the ax, they have to give you the f of x total value. And we will solve for this equation. We'll solve for a of x. We will solve for the factors. It's a really neat chapter when we get to this. So we'll get there. Not yet. All right, let's look at example 3. In example 3, we have solving a radical equation. That's the only difference here. So we're solving a radical equation. And so they're giving us the square root of 2x minus 1 plus 2, and that is equal to x. So the first thing I want to ask you to do is isolate the radical. So that means that step 1 is, let's get rid of the 2 that's over here. So subtract the 2 on both sides. This puts us where we have the radical by itself, where we have 2x minus 1 is equal to x minus 2. And at this point, we want to get rid of the radical. To remove the radical, you always raise it to the power that the radical root is raised to. So in this case, this is the equivalent. If I look at this, this is really 2x minus 1 raised to the 1/2 power, because it's a square root, right? That's the theory behind what's going on here. If you've never seen that before, now you have. Same thing if this were cubic. So if this were the cubic root of 2x minus 1, in theory, this is just 2x minus 1 raised to the 1/3. Okay? Now, having said that, that means that what I need to do here is I need to raise both sides. What I do to the left, I have to do to the right. What I do to the bottom, I have to do to the top. In this case, left and right. I'm going to raise this to the second power so that I get 2x minus 1 is equal to basically x minus 2 squared, another special product. This is an a minus b squared, if you remember. This means that this is a minus b times a minus b, which gives me a squared minus 2ab plus b squared. Right? And so that means that I'm going to take this x minus 2, the special product, and I'm going to square it. And I'll go ahead and work it out just in case you need to see it. X minus 2 times x minus 2, which means that I'm going to get x squared, hence the first terms. Inner outer is going to give me negative 4x and then plus 4. The plus 4 is negative 2 times negative 2. The inner outer is negative 2x and negative 2x. Added together, that gives you that. All right, so here's what we have so far. We have 2x minus 1 is equal to x squared minus 4x plus 4. All right, that's wonderful. All right, so now we need to basically move stuff around. I'm going to go ahead and I'm going to subtract the 2x and add the 1. I'm going to subtract the 2x and I'm going to add this 1. And now I'm left with 0 is equal to x squared minus 6x plus 5. All right, and now I can factor that. Think of the two values that will multiply to give you 5. So we know we have 1 times 5. It's a prime number, so you don't really have much choice. And that means that this is negative times negative, which still gives you a positive. And I know that negative 1 plus negative 5 will sum up to give me this negative 6. So this is an x minus 1 times an x minus 5 situation. So my x solutions are positive 1 and positive 5. They're always the opposite sign. You do want to, anytime you have a radical, you want to check for extraneous solutions. That means that you have to go back to the original question and check that these both actually work. So we're going to have to go back to where we have the square root of 2x minus 1 plus 2 is equal to x, and we're going to solve to see if it's true. So we'll start with the 1. If I use 1, I'm going to say square root of 2 times 1 minus 1 plus 2 is equal to 1. You can already tell that the answer is not going to fly, because this is going to give you square root of 2 minus 1 plus 2 equal to 1. This simplifies to square root of 1 plus 2 equal to 1. Square root of 1 is 1, so 1 plus 2 is equal to 1, and that is not true because this becomes 3 equal to 1. Not true. So the 1 is a false solution. So we don't use the 1 as part of your solution set. Now repeat and rinse that process. Now we use the 5. So square root 2 times 5 minus 1 plus 2 is equal to 5. And you can already see the math that's going to work here. This is going to give you square root of 9, right? Because this is 10 minus 1 is 9. Plus 2 equals 5. Square root of 9 is 3, and 3 plus 2 does equal 5. So your only solution here is the 5 itself. So always check for extraneous solutions where there are radicals. This is an SAT concept as well. On the SAT, they always give you a question with a radical, and then they give you the trick answer. The trick answer is jump to this. No, you gotta check. Check, check, check. So I will do this to remind you, and you're gonna sound like a parrot by the time all is said and done, but you will get this correct, hopefully. So if you're watching a video, go ahead and pause it, and I want you to try this one. All right, so go ahead and try that and pause the video. Your solution for this one is going to be just a 6. Remember, you always go back to the original, plug in what you found as an answer, and see what you get. All right.